Let's look at an example of Newton's second law. First of all, let's review Newton's second law. Newton's second law is F net is equal to ma. So F net is the sum of the forces, such as F1 plus F2 plus F3 plus the rest of them. And you carry on m for mass and a for acceleration. So this is Newton's second law. So let's take a look at what is given. 4 astronauts are playing tug-of-war in space. Astronaut 1 and 2 are pulling on a rope with force values of F1 equal to positive 5 newtons and F2 equal to positive 4 newtons, respectively. Astronauts 3 and 4 are pulling on the opposite side of the rope with forces F3 equal to minus 1 newton and F4 equal to minus 7 newtons. Notice we see positive, positive, so these guys are pulling on one side of the rope, and we see negative, negative, indicating that these 2 astronauts are pulling on the other side of the rope. The rope has a mass of 3 kilograms. So we're supposed to find the acceleration of the rope based on the net or sum of the forces from all 4 astronauts. So we have a hint. The negative sign indicates that the force is in the opposite direction to those with the forces with a positive sign. And they want us to add all the forces in the same direction and subtract all the forces pulling in the opposite direction to find the net or the sum. We express our answer in one significant digit, such as 3 minus 3, 0.3, minus 0.3, 0.03 or minus 0.03. Notice each one of these is one significant digit because you only count the zeros to the right of the number. So we only see a number 3 or a minus 3, so that's one digit. We don't see any zeros to the right of the 3, so 0.3 is still one digit because the 3 is one digit. Same thing with minus 0.3, and the same thing with 0.03. Just the 3 is one digit, and the same thing with minus 0.03. So we don't put any units down. So we draw on our picture. Here's our rope. Here's our flag in the middle of our rope. We're pulling with astronaut 1 and 2 are pulling in one direction, and we have these as positive 5 newtons and positive 4 newtons, and we're declaring pulling to the left is positive. We're in space, so it really doesn't matter. So we're saying pull to the left is positive, and pulling on the opposite side direction is negative. So F3 and F4, they're negative values, so we're pulling in the opposite direction or to the right. So step 1 is to find the net force, so you just add them up. You add up all going in one direction, 5 and 4 going in the one direction, so 5 plus 4 is 9. Then you want to subtract off 1 from astronaut 3, so 9 minus 1 is 8. And then you want to subtract off astronaut 4's force, which is 7 newtons, and that is, and you add that all up, and that gives you positive 1 newton. And since positive is to the left, the net force is to the left. Now, step 2 is to solve for F equals ma. So we don't know what you're supposed to solve yet. So we go up here and we look, and it says find the acceleration of the rope. So we know that our equation is F net is equal to ma. So we want to solve for the acceleration. And since I can't make any bold values, I'll just put little arrows over the top. So we know F net is positive 1 newton, so I'm just going to carry this down and substitute it in for F net, and we know that this is equal to mass times acceleration. So the mass is what we need to solve for next. We need to go find that out, but I'm just going to carry this down one more time. 1 divided by n, 1 newton. So solve for mass. Mass up here is 3 kilograms. So we just need to substitute it in and not solve for it. So we're going to put in 3 kilograms. And we want to find acceleration in this case. So I'm just going to put an A out here. So in order to solve this problem, we need to divide both sides by 3. So you want to divide this side by 3. So our answer on the left-hand side is going to be positive 1 divided by 3 newtons. And we have 3 kilograms and acceleration, so we should really divide by the units too. So minus 3 kilograms on both sides. Minus 3 kilograms. So this is a newton per kilogram. And this is going to be equal to the acceleration on the right-hand side. So we know our acceleration is positive 1/3, but let's get our units correct here. So let's substitute it. Our acceleration is equal to positive, meaning to the left, 1 divided by 3, and a Newton. A Newton is a kilogram meter per second squared. That's the definition of a Newton. So we have to put our kilogram in here and our meter. And we have to divide this by second squared. And then also in the denominator is this kilogram. So we have to put our kilogram over here as well in the denominator. And then we have to cancel like units, and we are left with what we expect, meters per second squared. So the acceleration of the little rope is going to be to the left with a value of 1/3 meters per second squared. And that is our answer. And notice that our answer includes not only a number, 1/3, but also a unit, meters per second squared, and a direction. The positive sign is giving us a direction, which is to the left. So we know that, and thus, and to be very clear, I will just put an arrow to the left. Even though we have a positive sign, we just want to make it clear it is to the left. So the answer is the rope is going to accelerate at a rate of 1/3 meters per second squared to the left.